Okay, so today we are going to start chapter 6 of NCERT book, that is triangles. Okay, this is the first topic of geometry of class 10th, right? So first I'll show you one video, just watch it.
Welcome to the lesson on similarity. At the end of this lesson, you will be able to identify similar figures and differentiate between congruent and similar figures. You will also be able to identify the conditions that define similarity of triangles and prove the basic proportionality theorem and its converse. You must be wondering why we're in a sports room during a geometry session. Well, there is geometry all around us. Let's try to find some here. Look at the different types of balls kept here. There's a football, a volleyball, a cricket ball, and a tennis ball. Ah, and here's a golf ball. That's quite a variety. All these balls are spherical in shape. Does this make them congruent? Objects are said to be congruent only if they are of the same shape and the same size. For example, look at these hockey sticks. They are equal in shape and size. Hence, they are congruent. As for the balls, though they are of the same shape, their sizes differ. Objects that are of the same shape but differ in size are said to be similar. Let's recap the definitions of congruent and similar objects. Congruent objects have the same shape and size, while similar objects have the same shape but may not necessarily have the same size. An important observation to note is that all congruent figures are similar, but all similar figures need not be congruent. Now, consider the geometrical figures given here. Let's sort the figures on the basis of similarity. Here, now all similar figures are aligned together. Let's analyze these figures to further understand similarity. All circles are of the same shape and their radii will always be proportional. Hence, all circles are similar. All squares are similar to each other as their angles are equal and their corresponding sides are proportional. Using the same logic, all rectangles are similar as the angles are equal and two pairs of corresponding sides are proportional. Now, let's check the similarity of triangles. On measuring the angles, we find that the corresponding angles are equal. On measuring the lengths of the corresponding sides, we find that the three pairs of corresponding sides are proportional. For two triangles to be similar, the corresponding angles must be equal, and the length of the corresponding sides must be proportional. To better understand the property of the similarity in triangles, let's perform a small activity. Cut a triangular-shaped piece of cardboard. Let's call this triangle ABC. Now hold it between a light bulb and the wall. Can you see the shadow of the triangle? It is an enlargement or magnification of the cardboard triangle because light propagates in a straight line. Let's mark the shadow of the triangle as A dash, B dash, C dash. Consider the point of the light bulb as O. Draw rays OA, OB and OC originating from point O. If we extend this ray further, we'll observe that A dash lies on ray OA, B dash lies on ray OB, and C dash lies on ray OC. This means that the triangles ABC and A dash B dash C dash are of the same shape. However, their sizes are different. So we can say that triangle ABC is similar to triangle A dash B dash C dash, and vice versa. Mathematically, similarity is represented as shown. Here, vertex A corresponds to vertex A dash. Vertex B corresponds to vertex B dash. And vertex C corresponds to vertex C dash. Symbolically, these correspondences are represented as A dash, B dash, and C dash. Similarly, angle A is equal to angle A dash, angle B is equal to angle B dash, and angle C is equal to angle C dash. And all pairs of corresponding sides of the triangles are proportional. Note that the same ratio of the corresponding sides is referred to as the scale factor. Next, we will discuss an important theorem based on the similarity of triangles. This theorem is called the basic proportionality theorem or the Thales theorem.
This theorem will be our first theorem and most important theorem of this chapter. That is called basic proportionality theorem or Thales theorem. Okay, mathematician Thales have given this theorem. That's why we can tell this theorem as Thales theorem also. Okay, now listen very carefully. After that, one by one concept I'll discuss.
The basic proportionality theorem states that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. A triangle ABC is given such that a line drawn parallel to side BC intersects the other two sides AB and AC at points D and E respectively. If we prove that AD upon DB is equal to AE upon EC, then the theorem will also be proved. To prove this theorem, join B to E and C to D. Also draw two perpendiculars, DM on AC and EN on AB. Let's begin the proof. Consider triangle ADE and triangle BDE. The area of a triangle can be calculated as half of the product of the base and the corresponding height. This means the area of triangle ADE is half the product of the base AD and the height EN. Similarly, the area of triangle BDE is half the product of the base DB and the height EN. Now, let's divide the areas of the two triangles. On simplifying, we can see that the area of triangle ADE divided by the area of triangle BDE is equal to side AD divided by side DB. Let's assign this observation as equation 1. Now consider triangle ADE and triangle DEC. The area of triangle ADE can also be calculated as half the product of the base AE and the height DM. The area of triangle DEC is equal to half the product of the base EC and the height DM. Now, let's divide the areas of the two triangles. We can see that the area of triangle ADE divided by the area of triangle DEC is equal to AE divided by EC. Let's assign this observation as equation 2. Consider triangle BDE and triangle CED. The area of triangle BDE is equal to the area of triangle CED because these triangles are on the same base DE and between the same parallels BC and DE. Let's assign this observation as equation 3. From equations 1, 2 and 3, we get the following expression. This implies that the ratio of sides AD and DB is equal to the ratio of sides AE and EC. Thus, the basic proportionality theorem is proved.
Okay. So you observed this video, so you got the idea about similar and congruent, these two words. So now one by one we'll understand the concept, right? So first is, you can see here three figures, same figure, Taj Mahal. Okay, so here if you'll observe, okay, so here what you are observing, first one is little bit bigger, then second one is little bit smaller than first one, and third one is smaller. All these figures are not congruent. If you will keep any figure on other figure, it will not be coincide to each other. So it is not congruent, but they are similar. Now, what is the meaning of similar that we'll understand. When two polygons of the same number of sides are similar, if their corresponding angles are equal and their corresponding sides are in the same ratio, that means or proportion. First of all, two polygon, if you'll consider, whether it is triangle or quadrilateral or pentagon or hexagon, if corresponding angles are equal and corresponding ratio of corresponding sides are equal, then we can say that two polygons are what? Similar. Okay, now see the next slide. Here you can understand through this activity. Here one bulb, and here if you will keep one quadrilateral, then its shadow you will get, and these two figure will be similar figure, and this will not be exactly same in size, but their angle, corresponding angles are equal, and ratio of their sides also will be equal. Sakshi, understood?
Yes, sir.
Okay. Sneha, understood now?
Yes, sir.
Okay. Now, so what is the definition of similar? If two triangles are similar, then what we can say? So similar triangles are triangles that have the same shape but not necessarily the same size. Shape will be same, but it is not essential their side will be same. Got this meaning of these two words? Same shape but not same size. It will keep one triangle on other triangle, then they will not they will not be coincide to each other. Now symbol of similarity will be this symbol. You can observe this symbol. So here triangle ABC similar to a triangle DEF. If these two triangles are similar, then what things we can say equal? Angle A will be equals to angle D, angle B equals to angle E, angle C equals to angle F. And ratio of their corresponding side, AB divided by D equals to BC divided by EF equals to AC divided by DF. Now, we can start exercise 6.1. Now, tell its answer. Answer first. Fill in the
So
blanks using
similar.
the correct words given in the blank. So, all circles are what?
So similar.
Similar.
Similar. All circles are not congruent. Some circle will be smaller, some bigger. They are not congruent, but they are similar. So always all circle will be similar. Now second answer. All square are
Similar.
here also similar. Then third, all triangles are similar. All what? Isosceles triangle or
Equilateral.
equilateral triangle?
Equation. Because
Equilateral.
equation,
Yeah,
all sides are equal.
right. Equilateral triangles are similar because they are always, we know that each angle of equilateral triangle equals to how much? 60 degree.
So 60.
So corresponding angles will be equal and ratio of their sides will be equal. Okay. Now fourth. Two polygons of the same number of sides are similar if their corresponding angles are what?
Equal.
Equal. First one will be equal and second one be their corresponding sides are proportional.
Proportional.
Proportional. Okay. So understood?
Yes, sir.
Okay. Now, next question, question number 2 of 6.1. Give two different example of pair of similar figure and non-similar figure. Anything, two things you can tell which are similar figure. Now you have learned two circles. You can say two circles are similar figure.
Also, two rectangles having different sides but the same shape, they will have
That
some.
also two rectangle you can say. Okay. And we know that corresponding angles will be equal. Sneha, is it or not? So
Yes,
any
sir.
example you can give. Non-similar figure. One is triangle, other is quadrilateral. Non-similar.
Sir,
Uh,
sir, so every congruent, suppose there are two triangles, they are congruent. So means they are similar to, like the all congruents are
yes, very
similar.
good question. The all congruent figure will be similar also, but all similar figure will not be congruent. Very nice. Now question number 3. Question number 2 to I discuss according to your thinking you can give answer. Right. Now answer 3. State whether the following quadrilateral are similar or not.
They are similar.
Sakshi, according to you?
Sir, they are not similar because the angles are not
Yes.
equal.
Sneha, look here. This angle and this angle, this is 90 degree, but here we can observe these two angles are not equal. This angle and this angle. So if corresponding angles are not equal, then we can't say they are similar. So here they are not similar because their corresponding angles are not equal, right? So this was 6.1. Now 6.2, that is the main topic. Okay, 6.1 was easy topic, so easily we have finished this. Now similarity of triangles. So what we have learned, when we can say two triangles are similar, their corresponding angles will be equal and ratio of their corresponding sides will be equal. So that already you have learned and I have shown this. Now this is the photo of mathematician, great mathematician Thales, and he has given basic proportionality theorem, and its name, other name is Thales theorem also. Okay. Now according to Thales theorem, now I'm explaining, this is very important theorem, that's why I'll prove also, and in video also you have observed how we can prove Thales theorem. So if a line is drawn parallel to one side of triangle to intersect the other two sides in distinct point, the other two sides are divided in the same ratio. So I am also proving this. So draw a triangle, any triangle we can draw. Now draw a line parallel to its base. Just draw this. Give its name of triangle A, B, C, and this point is D and this point is E. Right. Now in construction part you have to join B and DC. Okay. Now from E, draw a perpendicular EF, and from D, draw a perpendicular DG. So what is given? Here given part is in triangle ABC, DE parallel to BC. This is given. Okay. Now to prove. So we have to prove AD by DB should be equals to AE by EC. Now construction. So what we have to do? We have to join BE and CD. Then draw EF perpendicular to AB and DG perpendicular to AC. Right? Now, it's proof part. So I'm showing its proof part. Here ADE, area of triangle ADE divided by area of triangle BDE. So we know that area of triangle is half base into height. So in case of triangle AD, half base will be AD and perpendicular will be EF. And in case of BD, half DB equals to into EF. For both cases, perpendicular from E will be same because only one perpendicular we can draw from E to AB. So here for both triangle, altitude will be EF only. So we can cancel half and half, EF and EF, and we are getting AD upon DB. And this is equation number 1. Then we can write similarly area of triangle ADE divided by area of triangle CED will be AE upon EC. No need to prove. Similarly, just you can tell. But in video, you observe they explain more. But this much if you write, that is sufficient. Now, left hand side if you observe, numerator to same. But area of BD and area of CD, these two triangle, if you observe, lies on same base and between same parallels. So we know that triangles on the same base and between same parallels, right? Triangles on the same base and between same parallels are equal in area. Where you got this concept? Have you got before that?
Yes, sir. It was in ninth standard, no?
Very good. In ninth standard, we got triangles on the same base and between same parallels are equal in area. Even we got parallelograms on the same base and between same parallels are equal in area. So what we can say? From here we can say area of triangle BDE equals to area of triangle CD. If these two triangle, area of these two triangle are same, it means left hand side are equal. After that, we can say that therefore area of triangle ADE divided by area of triangle BDE equals to area of triangle ADE divided by area of triangle CED, right? If these two are equal, so we can say that AD by DB equals to AE by EC. So this theorem is called basic proportionality theorem. In short form, we are saying BPT. Its other name is Thales theorem. Is it clear? Now, I'm changing slide. Okay, fine. Now, next theorem, just check. Theorem 6.2. Its name is converse of BPT. It is converse of BPT. Basic proportionality theorem. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So here proof is not required, only motivation is required. Suppose a triangle, give its name A, B, C, and here D and E. So what is given according to this theorem? If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. That means here just opposite of BPT is given. So here it is given if AD by DB equals to AE by EC, then we can say that DE parallel to BC. But in BPT it was if D parallel to BC, then AD by DB equals to AE by EC. Here just it's opposite. If ratio are equal, then we can say that D parallel to BC. Sneha understood?
Yes, sir.
Sakshi understood?
No, sir. The last one I didn't get it.
Okay. According to converse of BPT, if this ratio AD by DB and AE by EC, these two are same, then we can say that D parallel to BC. Here it is not given, your D parallel to BC. Here it is given, your this ratio are equal. If
Sir,
ratio
then
we
how
can
we
prove
prove?
equal, then we can say D parallel to BC. समझ में आया?
सर लाइक ये सर आ गया इसका कोई प्रूफ लाइक कॉन्वर्ज है तो
नहीं
हाउ वी
प्रूफ
विल
है बट सिलेबस में नहीं है, दैट्स व्हाई आई एम नॉट
ओके
टेलिंग द
ओके
प्रूफ. पहले था, अभी वो सिलेबस में नहीं है, दैट्स व्हाई आई एम नॉट telling. But here one corollary of BPT also you have to remember. That also I am sharing with you. Corollary of BPT. Short form is, so here corollary of बीपीटी। कभी कभी इसको भी यूज करना होता है हम लोग को। तो अकॉर्डिंग टू दिस corollary of बीपीटी, ABC, suppose ABC is a triangle and D parallel to BC. That means here it is given D parallel to BC. ठीक है। तो according to BPT we can say that AD by DB equals to AE by EC by BPT. Okay, now take reciprocal both sides. So we can write DB by AD equals to EC by AE, लिख सकते हैं ना। Now add both sides 1. DB by AD plus 1 this side also, and EC by AE plus 1 this side also. Now take LCM. So left hand side AD and numerator will be DB plus AD, right? And right hand side A is the LCM, then EC plus AE. अच्छा साक्षी एक चीज बताओ, DB प्लस AD, DB प्लस AD को क्या लिख सकते हैं? AB लिख सकते हैं ना?
Yes, sir.
अच्छा EC प्लस AE को क्या लिख सकते हैं? AC।
Yes.
फिर दोबारा बोथ साइड रेसिप्रोकल कर दो, AD बाय AB इक्वल्स टू AE बाय AC, और इसे क्या बोलेंगे हम? corollary of BPT, right? AD by AB equals to AE by AC, और इसको हमें कुछ कुछ क्वेश्चंस में यूज करना है। सो अंडरस्टूड। बीपीटी का अकॉर्डिंग तो बोल सकते AD by DB equals to AE by AC। अब अगर कहीं पे जरूरत पड़े जो AD by AB यूज करना हो तो भी हम बोल सकते हैं, किससे बोल सकते हैं? corollary ऑफ बीपीटी, मतलब बीपीटी का एक अलग रूप। So understood?
Yes, sir.
Okay, fine. Now अब आ जाओ क्वेश्चन में, ठीक है? And this is the first question of exercise. This is exercise 6.2. So first question, it is given figure दे रखा है, two figure, this figure and this figure. अब हमें find करना है, find EC. So answer 1 I am showing. So answer 1 में देखो D तो parallel to BC दे रखा है ना, D parallel to BC। सो क्या बोल सकते हैं बीपीटी से? AD by
D is equal to AE by AC.
AE by क्या हो गया EC, right? Now put the value of AD कितना है 1.5, DB कितना है 3, AE is 1 and EC we have to find. Now cross multiply 1.5 EC equals to 3. So EC equals to
2 centimeter.
3 divided by 1.5. Now if we'll remove point, then we have to put here 0. So 30 divided by कितना हो गया 15.
15.
So 15 2 जाए 30. So EC equals to 2 centimeter. Right? So understood?
Yes, sir.
Okay. Now its second answer. So second one, since DE parallel to BC, right? DE parallel to BC होने से क्या बोल सकेंगे? AD
AD
by DB equals to AE by EC. इसमें ब्रैकेट में लिखो by BPT. यहां पे भी लिख देना by BPT. अच्छा, AD तो we have to find, and DB is given 7.2. AE का वैल्यू 1.8 and EC कितना है 5.4. So AD by 7.2. Since these two are the like decimals, so we can remove point. 18 3 जाए 54. So AD equals to 1 by 3 into 7.4, 7.2. So AD we are getting, if we will divide by 3, 3 2 jai 6, 3 4 jai 12. So AD we are getting 2.4 centimeter. Understood? Sneha? स्नेहा समझ में आया?
Yes, sir.
Okay. Now, next. Now next question. Okay. E and F are point on the side PQ and PR respectively of a triangle PQR. For each of the following cases, state whether EA parallel to QR or not. So here figure is not given, so we have to draw figure. So just I'm showing its first part. A, B, sorry, here we have to take PQR.
PQ.
Did mention in question, so PQR will take. So P, Q, R. E and F are point on side PQ. So यहाँ पे क्या है E और यहाँ पे है F. अच्छा. So first question I'm doing. So here it is given PE equals to 3.9 centimeter. Then EQ equals to 3 centimeter. Then PF 3.6 centimeter and FR 2.4 सेंटीमीटर. सो बताना हमें बीपीटी यूज करना है इसमें ना कन्वर्स ऑफ बीपीटी यूज करना है. साक्षी,
Yes, sir.
इसमें बीपीटी यूज करेंगे या कन्वर्स ऑफ बीपीटी यूज करेंगे?
सर यहाँ पे कन्वर्स ऑफ पीपीटी क्यों करेंगे, क्योंकि यहाँ पे वो दिया है कि पैरेलल है इसमें.
बिकॉज यहाँ पे पूछा है ये पैरेलल टू क्यूआर है कि नहीं.
तो सर की बस वो
ऑब्वियसली हमें
फर्स्ट
क्या करना है, वी हैव टू चेक रेशियो आर इक्वल और नॉट. पहले देख लेते हैं. तो
Yes,
P
sir.
बाई ई क्यू का वैल्यू कितना होता है वो देखते हैं. पीई अपॉन ई क्यू कितना होगा? दैट इज 3.9 अपॉन 3. So 3 1 is 3. That means 1.3 we are getting. Now PF upon FR. So here we'll get 3.6 upon 2.4. So 36 divided by 24. 12 से काट सकते हो. 12 3 जाए, 12 2 जाए. कितना हो रहा है ये? 1.5. अब यहाँ पे 1.3, यहाँ पे 1.5. सो क्या ये दोनों रेशियो इक्वल है?
नो सर.
सिंस P by EQ not equals to PF by FR, so we can say that EF not parallel to, काट दो इसको, QR. So understood?
Yes, sir.
Sneha, understood?
Yes, sir.
Raise two questions you will try. You will check if a ratio are equal or not. Equal हुआ तो पैरेलल होगा, इक्वल नहीं है तो पैरेलल नहीं होगा. तो आज का क्लास में हम लोग क्या सीखा? बीपीटी. बीपीटी का थियरम प्रूव करना, अच्छी तरीके से प्रूव करना है. यू हैव टू प्रूव दैट बिकॉज इन एग्जामिनेशन यू विल गेट, यू कैन गेट. ओके, क्योंकि बीपीटी आने का चांसेस बहुत होता है एग्जाम में. सो दिस थियरम विल कीप प्रॉपर्ली. ओके, then some questions we did. We understood the meaning of similar figure and congruent figure. ठीक है? So here I'll end today's video. One more video I'll make to complete this exercise. Okay.